Talk about more ways to find x-intercepts. So before we do that, you are going to need to know what graphing form looks like, which you should kind of remember just because it's very similar to absolute value. So we sometimes call this, or we typically call it vertex form, but some people refer to it also as graphing form. All right, so vertex form for a parabola is y equals a times x minus h squared plus k. And just as a reminder, because like I said, it is similar to absolute value and what everything does. So if you guys remember, the a value represents the vertical stretch and compression. Okay, and we'll get into more detail later. This is just a general idea. The H controls the translation right or left. And if you guys remember, it's always the opposite. So for example, if it's x minus 1, that means it goes to the right one. If it's x plus 4, it goes to the left 4. And k moves it up or down. Okay. So we're going to go ahead and look at an example. We want to sketch the graph of y equals x plus 2 squared minus 9. And the other very important thing that I should have added above here is that the vertex is h comma k. So that comes from here and here. Okay, so in order to sketch the graph, there's a few things that we need. So we need to, we need to find the vertex. All right, so the vertex, if it's h comma k, since it's x plus 2, it's going to be a negative 2. And since it's minus 9, that stays, and it's a minus 9. All right, so when we're sketching a graph, we need the vertex, and then we need a few other points. So we are going to go ahead and find the x-intercepts. And remember, we just learned how to do this yesterday using the zero product property. So we are going to talk about two different ways to do this. So I'll say that this is way A. So we know that when you find the x-intercept, you have to make y equal 0. So this would be 0 equals, and then we have x plus 2 squared minus 9. All right, so we know that if we have x plus 2 squared, that actually means x plus 2 times x plus 2. So the first thing I have to do is actually multiply that out, because what I'm trying to do is turn this into standard form so that way we can factor it. So I know a lot of us like to multiply using the box, so I'm going to go ahead and do that. So x plus 2, x plus 2. So we get x squared, 2x, 2x, and 4. Okay, so that means that these two would combine. So we now have 0 equals x squared plus 4x plus 4, but we also have the minus 9. So then we need to combine those two terms. So we'd have 0 equals x squared plus 4x, and 4 minus 9 is negative 5. All right, so we can see that this is the reason why this is called more ways to find x-intercepts. If we look at the title, is because this is obviously a different way than yesterday because it's in vertex form. So we had to multiply it out, and now it's finally in standard form. So then now we can factor it. So going back to factoring, we know that in the first box, we put the first term. The last box is the last term. So we can make a x. I know the product goes on the top, so I take x squared times -5, and I get -5x squared. And then I take the middle term, and that goes on the bottom. So I need two numbers that multiply to -5 but add to 4. So that would be 4x and -x, or -1x. So I take those numbers, or factors, and I place them in the boxes, and then I come up with the edges. So I get x times 5 is 5x, and x times -1 is -x. And that makes sense because 5 times -1 is -5. So then I take my factors, x plus 5, x minus 1, and set them equal to 0. Okay, now using the zero product property, we know that this means that we can separate it and say x plus 5 equals 0 and x minus 1 equals 0. So then we subtract 5, so x equals -5. Over here we add 1, so x equals 1. All right, so now we get our x-intercepts are -5, 0, and 1, 0. So that was quite a bit of work for one problem, right? So I'm going to show you a second way to do that. So I'm going to go back and write our problem. So we would still start it off the same way to find the x-intercept. You make y equals 0. But because it's in this specific form, we can actually solve it in a different way. So let's just try and get x by itself. So in order to do that, we would want to add 9 to both sides. So we would get 9 equals x plus 2 squared. Now we have to think, how could we undo something squared? Well, we could square root it. So to undo something being squared, you can square root it. The problem is, if we are square rooting 9, there's actually two different answers. We could have plus or minus 3. Okay, that's very important. So that's how we write plus or minus 3. The reason for that is 3 squared is equal to 9, but also -3 squared is equal to 9. So we get plus or minus 3 because we square rooted something being squared. You just get this. And then what I like to do is kind of make this two different equations. So we'll have x plus 2 equals +3 and x plus 2 equals -3. And then you're going to solve. So you subtract 2. So x equals 1. Subtract 2. So x equals -5. So then our x-intercepts are 1, 0, and -5, 0. So that was definitely a little bit more advanced. However, when you look at the process versus A and B, it takes a lot less time. Okay, but going back to what this example wanted us to do, it said sketch the graph. So we now have the vertex and the x-intercept, so that will be good enough for our sketch. So I'm going to go ahead and set this up. Okay, so if I remember, so our vertex is going to be -2, -9. So we'll go ahead and start with that. So -2, -9. And then our intercepts are -5, 0, and 1, 0. And we can see that the vertex is halfway in between those intercepts. And again, I'm just doing a sketch. So typically, if I asked you to graph, we would actually want 5 points. But since this is just a sketch, we're just going to do the vertex and the x-intercepts. All right, so that just talked about a different way to find the x-intercepts. And then again, we practiced graphing and finding the vertex.